Thanks for joining us today. We're going to be talking about NanoSTAKE, the revolutionary mini staking technology. So to give you an overview of Extol, real quickly, we have engineering services, plastic assembly technology, and custom automation. And our topic today is just in one area of the plastic assembly technology. So that is NanoSTAKE, which you can see circled on the screen there. It's one of two different staking technologies that we offer, and we'll go into that as we move forward here. So I'm going to let Sam take over. You can take over the slides and take it away. And of course, ask questions along the way. We want to make this as engaging and interactive as possible. So if you have questions, please type them in the chat. We'll do our best to answer them as we go along. You don't have to hold your questions to the end. We'd rather get those taken care of as they come up.
Kind of soft. We want to have this collaborative meeting. I think the flow usually works a lot better that way.
Yes.
So good morning, everybody. My name is Sam Starkey, and I'm the sales engineer here at Extol for the staking products. So both NanoSTAKE, which we'll be talking about today, and InfraStake as well, which we actually did a webinar on a few weeks back. So a few of you may be joining us from that one as well. So we'll kick it right off. First, wanted to kind of jump into a little video here on NanoSTAKE. So I'm going to play this. Hopefully it comes through okay for everybody, and then we'll talk about what we saw. Okay, so basically that was just a real quick depiction of what the NanoSTAKE technology can accomplish. I just wanted to start off, this is a conductive technology, so we'll get into that a little bit deeper later, but it is a conductive technology. There is a heater core at the end of that NanoSTAKE punch. And we call the tip the punch. That is actually what forms the staking head. So the one key thing I wanted to note there is you can see right after the completed cycle, you can actually touch the tip. It does not stay hot. So that is something that sets us apart from some of our competitors that use conductive technology. So there are some safety benefits to this. And again, we'll get into that a little bit deeper as well.
Somebody's saying that they didn't see the video. Is there a play button on your screen? I think in some cases, teams won't play it when we play it. And if there's a little play button on your screen, go ahead and click that. The video is only 13 seconds long, so you can kind of watch it and then get caught up. Did anybody else not see the video?
We'll move forward. I want to make sure.
Yeah, because the video is it
had to hit play.
Yeah, that unfortunate Microsoft can't figure out how to do Teams correctly. I don't know, but
all right. Well, I'll give you guys a few more seconds to let that complete. Now that everybody probably knows they have to hit play now. So
yeah.
So what that's doing is it's going through its heat cycle, its cool cycle. You'll actually hear the cooling air turn on. So right underneath or at the bottom of the module tip, there are some cooling channels there, and we are driving cooling air through that module once it's performed its cycle. So it goes through a melt phase where it melts the material. An integrated punch in there actually forms the staking head, and then we flip over to a cooling cycle where it brings everything back to a hardened state and then retracts. So we'll go over a little bit more of the staking process. So in the first cycle, we come down with our module and we interact with the plastic at this point. We do have a heater core in there, and that is our melt phase where we're tracking melt temperature. It will then drive as it melts. It'll apply pressure and it'll form the staking head to its final height. So we are tracking temperature and position. So there are some integrated SPC controls in here that a lot of the QA folks will love to hear about. So from once it's met its final height, the machine has said, "Yep, I've come down to the correct location." We'll flip over to cooling, and that's where the cooling air is introduced and comes out through those vents. And that is also set to a cool temperature predefined by our customer. So they'll set what temperature we want that module cooled down to. It'll meet that and then retract. And at that point, the cycle is complete. So why was NanoSTAKE introduced by Extol? So historically, we have had InfraStake, which uses IR technology. We have a couple different options there, 32 millimeter body and a 20 millimeter body. So we do have a couple different options, but not nearly as small. And also there were some different challenges. So both technologies are very safe for PCBs and sensitive components. But this one really targets those smaller applications where we just couldn't get infra into a tight packaging space. So everything is getting tighter, and with the introduction of a lot more electronics in automotive and appliance and things like that, there's a lot more PCB boards. There's tighter packaging spaces. So this was really introduced and developed for those challenging applications where we have, PCBs for LED lighting and electronics, and again, sensitive components. These do not produce really any off, like with vibe or other different challenging processes. They may leave behind some pieces of the plastic or things of that nature. This one is really great for sensitive components and PCBs. So again, we kind of touched on the quality, but we call that our smart respond heating technology. So if you were able to view the video in the beginning, you saw that immediately finishing its cycle, the operator can then really touch the tip of the module. So we have a really fast and really responsive heating technology with very precise control. So once it's done, it's cool. So it's a very low current. We have a closed loop process conditions that you can set into the machine. Again, kind of touching on that QA. So the steady state process temperature is very repeatable. We will track that. The system will track that. And really from part to part and piece to piece, really, we're getting a very consistent temperature, both heating and cooling. So when you pull up the graph and the data, it really is pretty steady across, that obviously that's taken into account that the parts are staying consistent. But if parts stay consistent, our machines and our process can be very repeatable part to part. The NanoSTAKE technology is easy to integrate into other products. One advantage is it's very low current and low draw. So there's a lot of other products out there that can accomplish a similar task, but probably not at 1.5 amps. So these, are very low voltage, very low amp draw, and not high voltage, small wire, small connections. We don't have any transformers or use of those that are usually large, power draws. So that is one clear advantage as well. The process is pretty fast. So we have an average cycle time, I would say, of somewhere in the 6 to 10 second range. So, that takes into account the machine coming into position, its heat cycle, its cool cycle, and its retract. So, as far as speed goes, it's a pretty fast cycle. I saw something pop up.
Yep. Question from Alan. What will the amperage be for a fixture that has 20 or 30 units?
So those will each stack if we're doing it in one press motion. Some of them are able to either switch or nest or cycle. So we might have an indexer. So it just depends on how many modules you have in place. But certainly that is stackable. So if it's a 1.5, 1.8, I think actually is the amp draw in duty. You would just then simply stack those to get your amp draw. So again, NanoSTAKE was introduced to fit in tight spaces. So our infra again was 32 and 20 millimeter body. This one's 8 millimeters, so about the size of a pencil. So we can really package these in small, tight spaces. There are some obvious limitations over infra. We can't do very large bosses like InfraStake. We're kind of limited to a 4x4 type package. We've done larger, depending on the materials. So some of the lower temp materials like polypro, we could certainly probably get away with something a little larger. But a general rule of thumb is we like to stay in that 4x4 boss size. So we can do very small bosses as well. So we've done some that are even hard to see to the naked eye, a quarter to half a millimeter. So again, these are kind of targeted towards very small components.
What's the max length of the tip?
Max length?
Yeah, like so that right now the NanoSTAKE module, how long is the actual punch portion of it? It's like
the
2 inches long.
Well, it depends on if you're talking about from the LED down to the base of the tip, or if you're talking just the punch. So, you're probably about 12, 13 millimeters from the bottom of the that black LED to the punch tip. So there's not a ton of space there, but we have an extended module as well. If you're wondering if we have longer to fit into tighter spaces. So there isn't much room here, but our extended module actually moves that by about 1.5 inches.
Yeah. So the actual the silver cylinder portion gets longer by 1.5 inches on the extended module.
Yeah.
Is that right? Yeah. Does that answer your question, or were you asking about just the actual tiny punch cavity tip?
Yeah, that didn't.
Okay, good. Sweet.
Yeah. And those, certainly after this webinar, reach out to us if you have an application where you need to get into a blind pocket or something like that. We can certainly review those and get you more specifics on what we can do there.
Yeah, we can take your data and we can lay modules in and see what will fit and what we can do to make sure we'll make it work for you. So this is the module design. So our core technology, a lot of those pictures previously showed the module itself. Those are typically installed with our 1-to-1 air cylinder. So when we use the modules, we will marry them up to a 1-to-1 cylinder, and then those will go on the machine. I just saw another one come in. How strong is the joint? That's a great question.
Yeah, that is. So with InfraStake and NanoSTAKE, we do apply a safety factor. There is less of a safety factor with Infra. We are, with the technology being conductive, we're driving the plastic through. We're not homogeneously bringing that to a semi-molten state. So in this case, to get a general rule of thumb, we take the parent material, tensile strength, and divide that by 2.25 or 2.5. Sorry, and so we'll take that material. Obviously it does depend on the size, the diameter, the through hole interaction. So the wider the through hole you have, the less strength you're going to get. We do have some software that we have actually built, so we can kind of get you a general, hey, this should produce this amount of pound-foot or Newton's force once the stake head is complete. So we'd love to help you there as well. If we pull that design in, we can try to get you some rough numbers of what you could expect.
And then we always like to recommend testing to verify the actual results once you've, but we understand you want to design for what you think will work and then, test it.
And just to put that into perspective, InfraStake, our safety factor is about 20%. So it is much lower of a safety factor, but again, two totally different technologies. So InfraStake is high strength, I would say, where Nano is medium.
Yep. Typically, we don't find that these smaller stakes for these types of applications, a huge strength requirement isn't there. Like we're holding a printed circuit board on. How strong does that actually have to be if it is? So
yeah, most of the time when we get this small, it's simply retention of something with not much force. So, but yeah, we can usually get you pretty close in estimate. So on that 1-to-1 cylinder, there is a hard stop limit built in if you choose to use that. It does prevent overstaking or over melting. So if there's a case where you have something, a situation where the components are very sensitive to that, you can apply this hard stop limit, and that will physically stop the module from driving any further. So really what drives these modules is the module controller, and these can be daisy chained. Our system will accommodate so each module controller will control 4 of the modules. So these can be daisy chained up to, I believe, 32 total. You can have, and then we can drive more than that, but then we would have to introduce another system controller, which we'll get into on the next slide, actually.
And they're small. I don't know if we have a picture of how small these things are, but
yeah, they're, I don't know, about the size of a piece of bread. Its footprint is about that little sucker,
like this little thing. So yeah, stacking them up is not a big deal. There's a question. Is there any recommendation in terms of materials? Are we going to get to materials?
There isn't an explicit list of materials. What I would say, though, is, really many of the melt processable materials. So these modules can get up to about 800 degrees Fahrenheit. So as long as your melt temp is south of that, which is pretty much most of the engineered thermoplastics out there, if you're south of about, I'd say, just to be safe, 750, 775, we can process those with Nano. We do get into some filler. I don't want to say restrictions, because we actually just introduced a new technology into the module tip, where we have offered hardened tips that have extended the life. Our legacy Nanos really had a problem with 40-50% glass fiber filler. It would eat away at the punch, but now we have a hardened tip option for glass filled materials, where that's really not an issue anymore, or significantly reduced issue. So there does have to be some care with glass fiber fillers, but pretty much if it's melt processable under 800 degrees, I would say it probably will sit.
What's the expected lifetime of the new tips working with glass filled?
So that really, again, just depends on how, there's a couple different factors. So how fast we're working that module and the percent of glass fiber. So just to give you an example, though, we are still gathering data on this new tip, but we had a customer that was running a glass filled nylon at 45% short fiber. They were getting roughly 20 to 30,000 cycles before the tips for the modules needed to be replaced. That customer was one of our first customers that we introduced this technology to after we did our feasibility study behind the scenes. We introduced that to them, and I think they just crossed 150,000 cycles with no noted wear. So although we don't know exactly how long we're getting, we can say it's significantly improved. So at this point, I can safely say you're probably going to get north of 150,000 cycles, even with a 45 to 50% glass fiber.
And 45% glass is a lot of glass.
Yeah,
Like,
we don't run into that too terribly often, but we do run into it.
yeah. So did you catch that? That was 20,000 before, and we're beyond 150,000 now. Oh,
We're
great.
Yeah, we don't know how long they're going to go. They'll probably, my guess is it's going to outlive the life of the module potentially.
Mm-hmm.
It's a significant improvement. So again, somewhat of a limitation or something to be aware of, but with the new module tips being hardened as an option, probably not so much anymore. So this is our system controller. So we offer a 10-inch interface as well as a 7-inch interface, just depending on how you want to fit that into your machine or our machine. Extol does build. We are a custom automated machine builder, so we'd be happy to build you a machine. We can also I'll get into it actually in the next slide. We do integration as well. So if you have a preferred machine builder already, we can work with you to integrate that into your equipment. And this is really, the system controller is really the heart and soul of everything, how the system drives, how hot it gets, temperature, position, time, all of that is driven from the system controller through the module controller. So here's kind of the integration layout. So again, if you have preferred machine builders there, you don't want Extol to build it for you, we certainly understand, and we can integrate that in. So we have an integration package where we supply all of the electrical components needed. We supply most of the pneumatic components that are needed. And then we would drive that or ship that in, and you guys would drive that into your and hook up into your system there. So this kind of just outlines what we provide and what typically the integrator provides, or the machine builder rather. We've done a lot of Frankenstein type packages too. So we can really approach really any type of solution we need. Some of the standard stake types, we see a lot of dome, we see a lot of puck. Actually, moving forward, our go-to design is more of a puck now, because we found that's a little bit stronger. So we'd see a lot of dome puck. We do a rosette style if, for whatever reason, serviceability, for instance, if you need something to be serviced, that rosette style is nice because you can actually stake and then drill out the center to allow that to then be serviced. So we see right now, a lot of screw replacement is happening with NanoSTAKE and InfraStake, because we can, even with servicing, you get the benefit of the molded in boss. And then if it does need to be serviced, you can drill those out and then drive screws on a hollow boss. So there's a lot of different options we're seeing now where screw replacement is gaining a lot of traction.
How can I know if the position I have set in the controller is correct? The NanoSTAKE is already installed.
Yeah, so that is something that if we built the machine, we would validate that with you at FAT. So we would say, hey, here's our parts. We do a 5 to 30 piece runoff. You would sign off on that. So it would be integrated in, and we would obviously set that position to your desired stake height at that time. If it's an integration package, we can certainly be on site. We have integration support, but those are adjusted and adjustable in the PL or the HMI. So there's really, it has to be taught. So there's a teach button in the system controller. So we would bring it down to its finished height. What we do is actually we snip the boss height. We don't drive any heat. So we would snip the boss, drive the equipment down to its final position. We would teach the equipment and say, hey, this is where we want you to go. And then and then the system then knows exactly where you need it to be. And you can set up SPC limits based on how tight you want that tolerance to be. And the system would then go to that position. If it didn't meet that position, it would flag the system.
Yeah.
So boss angles, we just want to touch on this so you're kind of aware there are some things that we need to take into consideration when we're looking at design. So the one on the left, best, we like to stay perpendicular to the work surface. That's always best. If we can't stay perpendicular to the work surface, we like to see the secondary or the secondary component on top of the primary. We like to see a design built in where the nano can actually ledge down into and stay perpendicular. Again, if we can't do that, it does typically reduce strength. We can still stake that head on the right that says port. It's just you're probably going to get a little reduction in strength.
But do you really want to be poor?
Let's be best for this. So angles and position of nano, as long as you're in that perpendicularity, really we can do it upside down from the side. It really doesn't matter at that point. So orientation is not necessarily something that we strive for. We can really stake in any position or orientation.
And each module has its own little actuation. So as long as the press brings the modules close and right above the stake point, then the modules themselves can fire in from every direction.
Yep. So NanoSTAKE or InfraStake, just kind of wanted to run through this. Again, boss size, the volume on InfraStake is much larger. It's almost 10x. So if we do have the ability to fit infra, that is our go-to technology. You do get a stronger stake, and so we can do those larger bosses. If we can't fit and we need to get into a tighter space, obviously that's where we would position nano. The tight spacing of where we can fit those. There are the one-to-one modules that do extend that footprint on the nano. So we do have to do some module lay-in to make sure the whole system does fit. But by and large, most of that is driven by the module size, the module body, which again is 8 millimeters compared to either 32 or 20. InfraStake does have integrated clamping. So if you are familiar with InfraStake, our modules actually come down on top of the part before any heating actually starts, and our module will actually clamp the part together. So no ancillary clamping is required with Infra. We do have to introduce that into Nano because there is no integrated clamping. Strength, we did touch on that. We typically like to say Infra is high strength where Nano is medium strength. So we would have to review that and kind of figure out what's best there. So again, just to recap, NanoSTAKE is really, easy and quick solution for very tight spaces. We didn't touch on it a lot, but or a little bit we did, but on the side of that body, you can see there is an LED down at the bottom. That is nice for a visual reference of what the module is doing. So it will turn red when it's hot. It will turn green once the cycle is complete and there's no faults. If you do get a module that faults, it will blink red so that you guys can easily identify which module it is. It may say module 10 is faulting, but if you've got 40 modules sitting in a machine, it's a little hard to identify maybe which one that is, where you can visually see which one is blanking and which one is having the problem. So that is a nice feature integrated into NanoSTAKE. And again, the independent process control. There are a lot of conductive technologies out there, but I don't know of too many that have integrated SPC capabilities into them to ensure that you have completed your cycle and to the right spot. So, and again, that can be integrated into your controls and your limits based on what you guys desire. I think that's
So
my portion.
if you guys have additional questions, go ahead and start putting them into the meeting chat. I'm just going to give a quick frame of reference about who Extol is and how NanoSTAKE fits inside of what we do. Extol exists to solve complex plastic manufacturing challenges. We do this all the time, every day. We're constantly solving tough challenges that other people struggle with. It's actually something that you can kind of see depicted in our logo. So we find there's companies on the left that have plastic welding expertise and other companies that have custom automation expertise. What we find is that plastic welding providers don't do well with custom solutions. So your application needs to fit inside of whatever box that they've designed. And that works in some cases, but not others. And then custom machine builders lack the plastic welding expertise to create a high performing solution. They can tailor their machine around your application, but they don't have the plastic welding expertise to make it high performing. Extol is the best of both. We have both plastic welding expertise and custom automation expertise. And so you can get a configurable plastic welding solution that is optimized for performance. And as we showed before, that takes place in three main areas: engineering services, plastic assembly technology, and custom automation. We can work with you throughout your entire project lifecycle, whether at the beginning with engineering services and you need 3D printed parts that you can try to use to validate your design. We can help you with development and coming up with the different joint designs that's going to work best for you, or help you choose a technology that's going to be optimal to meet your requirements. We can help you with prototyping so that you can prove out to yourself and to your customer that this is the right way to go. And then we can help you validate and make sure that what you designed is what you got. And then plastic assembly technology, we just spent this time talking about NanoSTAKE. We talked a little bit about InfraStake that's on there, but we have a whole bunch of other welding technologies that are available and that can be used in whatever application needs them. We have all these tools in our toolbox and we're process agnostic. So we look at every application, not thinking, how can I fit NanoSTAKE or InfraStake into this? We look at it and say, what is the best technology for this? And our team will actually look at your project and offer our recommendation. We might have 3 different technologies that will work best. We might say this one will work best. These 2 are other options if the first one for some reason has some issue. And then we, like we said, we can do custom automation. So we've built systems that are fully automated. Nobody has to touch the parts. They come out of the injection mold automatically and they leave on a truck on an automatic guided vehicle. We do semi-automated and then standalone machines where an operator is still loading parts into the machine and taking them out when they're done. And we can do integration packages. We do that with NanoSTAKE and InfraStake regularly. We also do that with our other technologies. So if you need laser welding and you have a machine builder or you are a machine builder, we can provide you with a laser welding package that you can drop into your automation system. All of these things we can do to try to help you solve whatever manufacturing challenge you're dealing with. So that's kind of the overview of who Extol is. Are there any other questions that we can answer while we have the time? Throat is tickling me.
Mounting system. Oh, just got a couple of them.
Okay. There's a mounting system preferred to ensure module perpendicularity. Oh, so pull up this picture. Where is that? This one. How do you mount these modules?
So those are mounted to the work plate depending on where or how they need to be oriented. So those are essentially locked in. So the platen, or the modules, in some cases, there's platens that move. In other cases, we just use the pneumatics on the 1-to-1 cylinder. But in either case, these 1-to-1 cylinders are locked and mounted to those either work surface plate or the machine itself.
Yep. What is the tolerance of the melt temp time and cooling temp in order to set the alarms in the controller? For example, the time 3 seconds, melt time 4 melt temp 460 and 160 for cooling temp. How I need to set the controller for this parameter in terms of alarms. Okay, I think what you're asking is, are you asking what tolerance the actual NanoSTAKE technology can hold, or are you asking what limits you should set for your application? Or maybe both.
Yeah.
We have a that screenshot. I don't think we do. I'm just going to pull this slide up, and we can kind of talk about the different limits. So, what is the tolerance of the temperature on a NanoSTAKE module?
So it does depend on where in that temperature range we are. There is a curve in which, obviously at the lower temperature, that band, or the bell curve of where that tolerance is tighter towards the low end. Once you get up towards the high end of 750, 800, it does start to taper off, and that tolerance band does widen a little bit.
Okay.
So as far as, we do have some of those temperature curves, so it really just depends on where in that range you're talking.
Yeah.
So specifically, we can gather that data to show you where in that curve you fall.
Mm-hmm.
So yeah, it's very specific to the application and where the temperature range is, but it's pretty tight.
And then as far as the control of this process, I want to make sure it's clear that this is a closed loop process. So we're heating to that melt temperature because there's that built-in temperature control into the heater. It's staking to a final height, and then we're cooling to a release temperature. Time is not really a parameter. The only time setting that we can add is between form and cool. We can add a dwell, right? So if you're finding that you want to allow that heat to soak into your plastic a little bit more, once it's reached its final height, you can add a second or two of dwell time to allow that plastic to just soak in the heat before we start to cool.
And although we don't suggest doing this by time, there is a section in the module controller or in the system controller that you can stake by time if you really want to.
Yeah.
But again, then that kind of takes away its SBC control of where it located. At that point, just heat for 5 seconds or whatever determined time, and it'll stop, whether it's completed or not.
Yeah. So the other comment here was, so he's giving the example 460 to 540, and then 460 to 200 release temp. I would think your release temp would want to be a lot lower than that.
Yes.
But is the temperature tolerance within plus or minus 40 degrees, or is it tighter than that?
Yeah, it's usually in that range. I would say it's tighter than that.
Okay. Process. Does the system require any type of warm up to start running the process? No, it does not.
Well, it's very short.
Yes. So the modules sit there at ambient temperature, and then when you tell it to go, they heat to operating temperature in a matter of seconds. And then once they're done, they cool back down to ambient. So you don't have to warm the tips up in the morning or anything like that. They are running at steady state right from the get-go.
Even at 550 or 600 degrees, it's under a second for warm-up.
Yeah. Process. Cool. Any other questions before we sign off and send you on your day? Process. We'll be having another webinar come up soon. Our website will have the registration for that. It'll be all about what we build for integrators. So if you are a machine builder and you want to join that, check out our website in the next few days to register for that. Can we download this presentation once complete? Absolutely. We will be sending out an email with the recording and also a PDF of the slides. process. With that, I want to thank everybody for joining. Thank you, Sam, for presenting.
Absolutely.
And if you have any other questions come up, feel free to send us an email or just respond to the email that you receive with your copy of this webinar. Thanks, everybody. Have a great day.
Thank you.